Hello everybody. This week in pipe fitting, we are learning to determine the correct pipe diameter for natural gas plumbing. Since I can't go to the lab and I have natural gas in my home, I decided to diagram my natural gas system and determine if the installer used the correct pipe diameter. To get started, the first thing you have to do is look at your appliances and add up their total demand. The total demand on my system is 271,000 BTUs per hour. The next critical piece of information is to find the longest run. Now, my system has two branches, the longest run being in this, we're going to call this branch 2, in this run to the space heater. Right there. The length of that run is 64 feet. To determine if I'm using the correct pipe diameter, I need to go to a chart like this one. This chart is for natural gas with an inlet pressure of less than 2 psi. And I called my provider and they confirmed that my inlet pressure is indeed below 2 psi. In fact, they said it was going to be somewhere between, and if I choose, somewhere between 3.5 to 7 inches of water column. If you convert that to PSI, you'll find out that it's somewhere about 1.25 to 0.25 PSI. So now that we know that we're using the correct chart, and you should have learned how to use this chart already, you'll see that we're looking for a length of pipe of 64 feet, in which case we have to round up to 70, and a capacity of 271,000 BTUs per hour, or 271 cubic feet per hour. In this case, we have to round up to 486, and we see that the correct pipe diameter is 1.25 inches. Looking back at our diagram, we can see that for this 4-foot run of pipe, the pipe diameter is in fact 1.25 inches, which is correct, and that's exactly what we need it to be. The next thing to do is to look at our branches. Now I'm going to take this first branch to the boiler because it's the easiest, and we need two pieces of information from this branch in order to determine if the diameter of pipe is correct. Those pieces of information are the total length from the meter to the boiler and the demand. So the total length is 12 feet with a demand of 180,000 BTUs per hour. Looking back at our chart, we can see that for a run of 12 feet, which we round up to 20, and a demand of 180,000 BTUs per hour, we round up to 247. The chart tells us that we need 3/4 inch diameter pipe. Back at the diagram, we can see that there was a short run, a 6-inch run of 1.25 inches, which is plenty sufficient, and then a reducer to 3/4 inch to the boiler. And that's all we need is 3/4 inch. So we know that this was also selected as the correct pipe diameter. With that branch out of the way, we can look at the slightly more complicated second branch here. We need again two pieces of information. The total demand on this branch, which does not include the boiler. The total demand on this branch is, was that 91,000 BTUs per hour. And then the length of the longest line is the same as the longest length in our system, which we already know is 64 feet. So we take those two numbers back to our chart. We look for 64 feet, round up to 70. We look for 91,000, round up to 126, and we see that we need 3/4 inch pipe. And that is just for that one length. This one length of 3-foot pipe needs to be 3/4 inch, which it is, so that's good, to supply this branch. We're going to keep going towards that space heater. The next piece of pipe we're going to look at is this 11-foot run of pipe. But we have to stick with the total length again of 64 feet. But this time we lose the water heater as our demand. So we can subtract the water heater from the fireplace space heater water heater sum of 91. So we subtract 40,000 and we get a total of 51,000 BTUs. Go back to our chart. Again, we're looking for 70 feet, the longest run in that branch, 51,000. 60 is the smallest number on this chart, and we see that 1/2 inch pipe is all we need. Go back to our diagram, we see that they chose 1/2 inch pipe and that's exactly what needs to happen. All right, then the last piece of pipe going to the space heater is this 46-foot run, the longest run here on this branch. And we see the load is 18,000. Again, we have to use that total length of 64 going out to the space heater, a load of 18,000. And I'm not going to bother going back to the chart. We already saw that. Well, you know what? Let's go back. We already saw that 60 was, 60 BTUs was the smallest number on this chart. At 70, the system is only asking for 18,000 at this point, and we know that half inch is perfectly fine. Now that we've settled the branches, we have to look at the drops. The only branch with drops is branch 2. The drops are the water heater and the fireplace. So for this drop, we just need to calculate the distance to the drop to the water heater. In this case, 4 plus 3 plus another 4, that's 11 feet. So we have 11 feet to travel. The demand on this branch, since we already calculated that we have the correct pipe diameters going to this branch, we just need the load on this branch now of 40,000. We go back to our chart, armed with 11 feet, rounded up to 20, demand of 40,000, and we can see that we only need a half an inch diameter pipe going to the water heater. Looking back here, you can see that the installer put 3/4. 3/4 is sufficient. The water heater is going to get plenty of gas. The last drop is the fireplace. The fireplace has a 4-foot drop. Coming off of this 11-foot drop, which we've already determined uses the correct pipe diameter, as well as the 3-foot and the 4-foot. We got to take the total length. So 7, 11, 18, and 4 is 22 feet. So we got 22 feet here for a demand of 33,000 BTUs per hour. We look at our chart, and we can see that for 22 feet, we round up to 30. Demand is tiny at 33,000. 95,000 is the lowest number on the chart, which means that we can get away with half-inch pipe diameter, and in fact, that is what the installer used. So as you can see, all of the pipe diameters chosen to supply this system were correct.